previously for another PPT file. So today I changed my lecture's contents. So in order to introduce some new ideas, new infrastructures in the field of urban integrated transport all over the world, including China, European countries, Japan, and the USA. I hope I can introduce something very valuable for the development of your countries, for the development of the urban integrated transport system. So let's begin. Oh, this is the outline. This is the outline of my lecture. Totally 3 parts. New urban transport systems in the world. The second part, urban integrated transport development trend. The third, let's have some summary. For the lecture, at this time, we totally reached for about 3 hours. If we complete these contents earlier, I will continue the next lecture. Let's have some beginning of the next lecture. Well, originally start from 6 o'clock p.m. in Beijing time. But if we completed this lecture earlier, let's have some the start of the next. Okay. Okay, 3 parts: new urban transport system, urban integrated transport development, and summary. First of all, I need you to focus here. Focus here. Transport demand management, sustainable traffic options, support the land use principles. Don't forget land use, transportation, demand, and supply. They interact with each other. This is the core idea of my lecture, okay? Never forget the land use, because if we don't consider land use in the field of transportation, we can do nothing, okay? Maybe you have heard about the principles that in foreign countries, for example, in US, in Europe, in Japan, transportation lead the land use. But in developing countries, including China, including your country, I think land use played the main role and transportation played the second role. I think it's wrong. It's very mistake. It's a very mistake. Okay. New urban transport systems. Let's have some discussions of the new systems. In the year, okay, this is the first new system in the world. It is called Palmer 2000, introduced in 1971. Okay, can you see its unique characteristics? Can you tell me? It looks like a bus or metro train or light rail, but it's a totally new system. Can you tell me which part is special? Hello, are you there? Can you tell me? This one, which part is special? It looks like a bus, a big bus. It looks like a small light rail train. Okay? But it's a totally new one. Can you tell me the special part of this urban transport system? Can you? Look at here. Oh, sorry. Look at here. What's this? Can you see? Can you see? Hello, are you there? Oh, okay. Yes. It's a light rail with different wheels. Well, join the buses and bus wheels on rail. Yes, you're right. You're right. A very small light rail train, but the wheels are made of rubber, running on tracks. Okay, running on tracks. It's a very small light rail train. In comparison to the light rail train, it has a comparatively small transport capacity. Okay, but it's still a rail transport mode. Usually in China, we utilize this train in very big airports. But in European countries, for example, in France, okay, they utilize this one for urban transport. It's slower than light rail train, but faster than bus. Okay? It is invented in the year 1971. It's called Perma 2000. Okay, 1971. Remember this one. Okay. Oh, sorry. Another one? What's this? Can you tell me? Very strange. Okay. Have you seen this before? And this one? Okay. Some kind of pod. Yes. Usually we call it port car. Port car. In the year 1972, it is called computer-controlled vehicle system. Okay. Demoed in the Expo 1975 in Okinawa, in Japan. In fact, it's a kind of personal rapid transit. Okay. Usually here in one vehicle, there were 4 or 8 seats. 4 or 8 seats. If no seats, maybe about 20 passengers, this train can carry. Okay. In 1975, this one was put into operation in Morgantown. Okay. It is also called the personal automated transport or port car here. Okay. But this one is not suitable, or we can say it's not very useful for developing countries or developing cities. Not useful. Why this one is invented in the year 1970s? First, in the society, for example, in US, in European countries, people are used to driving their cars, driving their private cars. How to make people abandon their cars and utilize public transport, then you need to prepare some travel mode, some kind of personal automated travel mode with the convenience of private car, with the speed of real public transport, and then this one is invented. Okay, it's not useful for mass rapid transit. Okay, once upon a time, one of the cities in my memory is Hangzhou. One of the cities in China intended to utilize this one to solve the problem of traffic congestion, but we failed. Okay, remember, never utilize this one to solve the problem of traffic congestion in the city. You can utilize this one to persuade people to give up their private car, but never solve the traffic congestion by utilizing this one. Okay, this is a maybe I should say very special, very special traffic mode. Okay, not useful for developing cities, but for developed cities in which people are used to driving their private cars. Okay, this one, maybe you have heard about this one. What's this? Can you tell me? What's this one? In Curitiba. You know Curitiba? Okay. Not metro. It's not metro. No. Kind of. It's metro? No. In Brazil, this system is in Brazil. Metro bus system like in Pakistan. I have never been to Pakistan. I don't know if you have this one or not. And this system, oh, sorry. This system was put into operation in 1974 in Brazil. Okay. The city in Brazil, the name of the city is Curitiba in Brazil. Okay. This is a bus. Okay. Bus Rapid Transit System, BRT. But it's a very special, very unique, very successful BRT system. Very successful. All we can say is it is the first successful BRT system in the world. But on dedicated road like the one we have Pakistan. Yes, maybe in your country you have introduced this system, but let's discuss something very special. Okay? This, something like capsule. Okay, this is the station. Like this, station. Okay? Enclosed station. And this is the bus, but not common bus. The bus is very long. You see? Available. BRT in Pakistan available. Okay, I see that. But listen to me. The bus is very special. 1, 2, 3. One bus vehicle consists of 3 parts. Very long, like a train. Okay. And if you want to take this bus, okay, wipe your card at the entrance of the station, and you can see like like the gate of the metro station. Okay, you can get in, and when the bus arrive at the station, you can see there is board will lying down, let people come in, get off the bus, and get off the bus directly and get into the bus. Okay, this is BRT, but it is operated, it was put into operation in the mode of metro train, like metro train, but it's BRT. And by chance, they have solved one of the biggest problems of metro system. Okay, everybody here knows that if we build a metro station, we need to solve the problem that if too many people want to get into the metro station or get out of the metro station, we need to solve the problems of the passenger flow congestion inside the station. But look at here. If you take this BRT, you can get off the bus and get out of the station directly. Okay, you see? BRT system operated in the mode of metro system and solve the defect of metro system or metro station. Okay? And another important point is that this system is very cheap, very cheap. Okay, in comparison to the system of metro. Okay, in the year 1970s, in Brazil, big cities in Brazil, for example, in Curitiba, there were very serious traffic congestions, very serious, or we can say too serious. And then people thought that if we want to solve the traffic problems and traffic congestion problems, let's have light rail or metro system. But we have no money. Okay, maybe everybody here knows that the building consumption of bus line, a metro line is very expensive. Okay, for example, in Beijing, for 1 kilometer, okay, for 1 kilometer metro line, including the stations, the building fee is 1 billion Chinese yuan for 1 kilometer. Okay, too expensive. In Brazil, yes, it is too expensive for construction of metro lines. So let's have something cheap but operated in the mode of metro system. And then this system was introduced in Brazil, in Curitiba. Okay, and people later find that, wow, it's really successful in the world. Okay, really solve the traffic congestion, especially in morning peak hours and evening peak hours. Why I introduced this? Another important point is that in peak hours, the bus will operate together, 3 together. Okay, one bus, another one, another one. 3 buses will operate together in peak hours. In other words, 3 buses will come to the station together and one by one to help people get off the bus and help people get in the bus and then start together like a train. Okay. In fact, it's a metro operation system, but the infrastructure is BRT. Okay, this is a very important idea I should tell you. In the future, road traffic system and the rail traffic system, they will become similar and similar to each other. This is the trend, okay, from the year 1970s, starting from 1970s, okay? Let's see another one. What do you see? Tell me. What's this? Tell me. What do you see? Hello? What about the problem of the feeding routes connecting to the BRT? You mean this one? The feeding route? They will use the Corman bus. This guide. Okay. This one? Sorry?
I wanted to ask that the feeding routes, they are a problem for BRTs because the feeding routes, they are not connecting to the buses and there is traffic problem still there for most of the BRTs in Pakistan. So the problem is the traveling public is not able to reach the BRT and the BRT is serving, but it is not solving the problem of traffic congestions. How did they overcome that in Brazil?
Sorry, I cannot hear very clearly. Could you repeat it, or you can type the word?
Let me type.
Oh, sorry, not very clear. Hello? Okay, you mean this system? This and what? Okay, the problem of traffic for trains. Okay, go on. Okay, you can type. Okay, let's see this one, and you can type your questions. directly here. Let's check this one first. And for others, when connecting routes are not properly connected to BRT. Not properly to BRT, not properly. Yes. And what's your question? You're focusing. How did we overcome that in Brazil? Okay. Oh, I got the point. Okay. In order to connect the BRT main lines, okay, they will have the common buses, but the common buses utilize other routes. You see here for the line of the BRT, other vehicles are not allowed to get in. Okay, this is the first point I can tell you. The second one, in order to have the connecting bus lines, they will use other system. Okay, and very good planning of the land use, very good planning of the traffic flow forecasting. Each BRT lines will connect the main passenger gathering points. Okay, can you understand? This is another point of the urban planning. Okay, first they have the urban planning, and then to get clear of the main points of the passengers, and then connect these points with the BRT lines. Inside the BRT lines, only such buses are allowed to operate inside. For other vehicles, for example, private cars, your motor vehicles, bicycles, even pedestrians, no, sorry, you cannot get in. Even common buses, no, utilize other roads. Okay? The collection points are somewhere outside. Yes, outside. Outside. In order to keep the fast, highly efficient operate of these BRT buses. In other words, in order to make this bus system operate like real metro lines. Okay? Yes, because it's on row A. Yeah. But the route of BRT fenced, not fenced. But if you drive your car, get into the BRT lines, then you will get a very good fine, very expensive. Or sometimes you will be prosecuted. You need to go to the court. Okay? Understand? Very serious law, very serious regulation. Okay. Okay, thank you. You understand? You see, yellow lines. Yellow lines means not allowed to get in. Okay, yellow lines everywhere. Okay, this is the very successful BRT system in Curitiba of Brazil. Okay, remember, in fact, it's metro system, but utilize road bus infrastructure equipment. Okay, road bus infrastructure, road bus equipment, but it's operated in the way of metro lines. Okay, fast, high efficiency, very low construction fee, very low operation fee. Okay, but remember, thank you very much for your question. Remember, very serious law. Never have other people or other vehicles get into the lines. Okay. Another one, this one, very special. What did you see? Oh, somebody told me that a bus with this one. You can see a bus, right? But running on tracks, rail tracks. Okay, running on rail tracks by utilizing this one. Okay, here, you can see this one is here. And then the bus can running on rail tracks. And this one, in fact, the same. They're the same, but the tracks are built for the buses. This is called guided bus, okay? Invented in the year 1980, okay, in Germany. This is the city in Germany, Essen, okay? Cars in the year 1970 and 1980s in European countries, including Germany, UK, and also in Australia. There was serious traffic congestions because more and more private cars. How to solve the problem? Okay, everybody was very headache at that time. And people find at that time that rail tracks are empty, even every day, even all the time. People didn't like trains at that time in European countries, in Australia, and also in US. People didn't like trains. They don't like riding a train. Even sometimes they didn't want to see a train inside the city. They believe that train, oh, sorry, train, it's old. It's not for a city. Okay? And few people take trains in 1980s. Okay? Rail tracks were empty every day. But on the road, there was very, very serious traffic congestions, even all the time, 24 hours in the day. And people in Germany invented this one. For what? Because if you want to take a bus, you only care which bus stop, which bus station you can get to, or you can arrive at. You didn't care between bus stops which route the bus take. So people in Germany at that time think that, okay, let's keep the bus stops, let's keep the bus stations, and then let's change the bus route between stations. Between stations, buses utilized rail tracks by very simple improvement of the bus vehicle. Okay. In this way, between bus stations, buses runs faster and faster. Okay, people save time if they take bus. Because if the bus running on tracks, then they avoid get into the traffic congestions on the road. Okay, and very fast. Later, people will build very special tracks for buses, not using not use the existing rail tracks. Okay, this system was invented in the 1980s in Germany as the first one. Until today, the guided bus system in this world has 5 successful guided bus lines in the world. In fact, this system is another special type of BRT. Okay, this one is BRT, operated in the way of metro. This is also BRT. Okay, BRT running on tracks between bus stations, between bus stops. Okay, remember what I told you? The difference between rail travel mode and road travel mode, the difference is becoming less and less. Okay, remember that. In the future, we will have a integrated transport system. Make the difference of different travel modes less, and less. Okay? You can see 1970s, this one, 1980, this one. Okay? In this world, we have 5 successful guided bus systems. Let's check one by one. Okay? Essen, in the year 1980, the first guided bus system in the world. Okay? In the year 1984, in Mannheim, it's another German city. Okay? It's a trammed system. In fact, this one is Mannheim. Okay? In the year 1989, in Australia, the city's name is Adelaide. Very fast, even faster than metro trains, the guided bus system, okay? 100 kilometers per hour, okay? Leeds, 1995, in UK. They use this guided bus system to skip the most important road intersection of the city in Leeds, okay? Nagoya in Japan. This guided bus system was put into operation in the year 2001. In fact, it's a very automated guided bus system. Even without a driver, the bus can run itself. But people find that if we don't have a driver in the bus, nobody dare to take the bus. So let's have a driver of the bus, but you can see the driver there just to sit there. Okay, all the operations of the bus will make itself. Okay, very automated. Let's check. Before we check these systems one by one, let's check the characteristics. One of the characteristics of the guided bus system. Okay, this is a guided bus system. Okay, with the tracks for the buses. Okay, this is the common bus system. What did you find? Can you tell me? What did you find? What we can save? Hello? What we can save? If we construct the guided bus system, yeah, we save the space. We save the resources, especially the land resource. Okay, remember, inside a city, land use, land resource is very limited. Okay, for a road system, they will take the main land resource inside a city. In this way, we can save about 1/3 or 1/4 of the land resource. Okay. Okay, let's check. Okay, let's check the guided bus system one by one. This is the system in Mannheim, in Germany. Okay, in the year 1984. You can see this is a railway station, a railway station in Germany. Okay, formerly, this is a train. This is a train in Germany. Okay. This is the guided bus just parking in the station of a railway train. How? You can see here, the rubber wheels of the buses are on these wheels, okay? And then with this one, for this part, you can see here another track. Can you see it? Another track here and here. You see? Tell me, you see this one? You see this one? Yes. This one and this one is for this. You see? Buses running on bus with a very special equipment. And then you can see this view, okay? Railway station. You can see train. You can see bus, okay? How to integrate different transport mode. This is one way, okay? Remember, don't forget, I have been always telling you the difference between different travel modes, especially the rail travel mode and the road travel mode, is becoming less and less. Okay? This is the trend in the future. Oh, this is guided bus in Australia, Adelaide, in 1989. Okay? You can see here, this is one of the guided bus running on the tracks. This way is the city center of Adelaide. This way is the suburban areas of Adelaide. Okay? Usually in a big city in the world, including China, including USA, including UK, if we want to connect the city center and the suburban areas, let's have the light rail. Let's have the metro line. Okay? But don't forget, it's expensive. Not only expensive, if few passengers, and then the operation of a light rail line or metro line will become a very big waste. And then guided bus system is a alternative travel mode we can utilize. Okay, not too many passengers, but we need fast travel. We need fast traffic and no traffic congestions. Then guided bus. Okay, that's fine. Connect the city center and the suburban areas. You can see the track, the bus with this equipment. This is the bus station. If you take the bus and you can see if the bus wants to get into the station, and then the track will become like this. And the bus will come here, get into the station. We have passengers get off and get in. And then, and this is another bus station, okay? This is another scene, just around the bus station. This is the bus station, you can see here, many cars, like this. How? Can you tell me why? This is the suburban areas. Why? Why can you find too many cars around the bus station in the suburban areas? Around the guided bus station? Do you know why? If you know, I will continue. If you don't know, I can tell you. Park and ride. Park and ride. Not park, not ride. Okay? Maybe you have known that. Park and ride. I don't know the case in your country. Yeah, people park their cars. Yes, park their cars there. I don't know the case in your country, but in European countries, in US, not in China, not in China, not in Japan, not in most of the Asian countries. If you live in the European countries or if you live in US, you can find that people will live in the suburban areas. For the city center, in the evening, I think it's dangerous. Cheap traveling from town to city. So people park there. No, okay, very good idea. Let me explain continually. Okay, in European countries and US, if you work in a big city, okay, if you work in a big city, you will not live in the big city. You will live outside the big city, in the suburban area of the city, especially when you are married, you have children. You will live outside the city, in the suburban area. And then every morning, you will drive your car to the city center to work. And then in the evening, you will drive your car back to your home. But another problem, a very, very serious issue is that traffic congestions. Traffic congestions in the morning, in the evening, in the big city. Okay? Not only in developing countries, but also in developed countries. And then later, most of the big cities, for example, in London, for example, in New York, not New York, London, Singapore, such big city, in the morning, if we want to drive your car, get into the city center, sorry, it's forbidden. It's forbidden. Okay? In Tokyo, okay, you can drive your car into the city, but later you will find that you cannot find a parking lot. If you can find a parking lot, you can find that the parking fee is too high, too expensive. Okay? In UK, if you drive a car into the city center in the morning, okay, especially in peak hour, okay, you will be prosecuted. You will have a very good fine because it's forbidden. In Japan, in Tokyo, if you drive a car into the city center in the morning, okay, maybe you are very, very, very rich. Okay, you have your private parking lot. Okay, so people are used to this living style. Drive their car to the metro station or bus station or light rail station and park their car around the station and then take bus to get into the city center to work. And then in the evening, take the bus or take the train back to this parking lot to drive the private car to get home. This is called park and ride. Okay? Park and ride not only for metro, not only for light rail, but also for this guided bus. This is the case in Australia, Adelaide. Okay. Okay, let's go to UK. This system. Okay. You can see this is the guided bus in UK, in the city Leeds. If you like football, if you like soccer, you know this city, Leeds. Okay. Not very big city with the population about 100,000. Not very big, but there were also traffic congestions. I have been there once, especially morning peak hour traffic congestion too. Okay, especially in the one main road intersection inside this here. So people in this construct this guided bus system. Okay, you can see here, this is the main traffic flow direction. Okay, here we can see the common road lane. This is the private car, private car, private car, private cars. Okay, this one, the blue big one. This one is the BRT. In fact, it's guided bus. Okay, guided bus. What I want to tell you is that this guided bus system has the prior of the signal. Prior of the signal. Okay, if the guided bus come into the road section, okay, this is 300 meters long. Okay, if the bus come here, if the bus comes here, and then the signal here for the bus will become green. The signal for these cars will become red. Okay, and then the bus will get through the road section very fast. Okay, in priority. Okay, here we can find the reader here to detect the coming of the bus and then change the signal and then stop these cars to have the bus go first. Okay, this is a BRT in this. You can see here, not the steel rail tracks, but the special tracks for the bus. See, this city. Oh, only for these 300 meters, we can find the tracks for the guided bus. If we come to other places, and then it is a common bus. You see, this is a common bus stop. Okay, and then for the elder, they have the bus the flat floor like this. Here we can see guided buses, maximum speed 20, and then we can find the reader here. No, not here, here. And then if the bus come here, other cars will stop there. Okay, let's have the guided bus go first. Okay, this is very important. So let's go back to check the first 3 guided bus system. Essen, the first guided bus system. Mannheim, tram system take advantage of the railway station. Okay, operate. The fastest, okay, the fastest, very fast BRT system, guided bus system, even faster than the metro train. Please skip the main road section with the priority of the signals, okay, to avoid the traffic congestions of the bus, whereas in the center of the city, okay, very special. Each system has the characteristics, okay. These. You can see here, these cars will stop at this side. And then the bus will come here, and go through the road section. Okay. Oh, and here, I want to ask you one question. Everybody here, I just heard from Clark that many of you are the officers in your countries, and also I think you have know the concept of the bus priority. Bus priority. What is bus priority? Okay. Please can tell me. Priority of the buses, of the lanes, priority of the buses, of the signals, priority of the buses of its development. These are the bus priorities. Without these contents, then we cannot have the bus priority. Do you agree? Do you? This is another guided bus system. Yes, bus should go first. Yeah. Yeah, bus should go first. How? How to go first? How to go fast? Go first. Go fast. Go to the places. Go to the places private cars cannot go to there. Understand? This is bus priority. Okay, yes. Thank you. This guided bus system, Nagoya, in Japan, okay? You can see the driver here. You see? But the driver there, well, he does nothing. Okay, just to sit there. Okay, first, the bus is controlled by the computer in automation. Okay. Without this driver, the bus runs itself. Without this driver, the bus runs itself. But without this, if there was no driver inside the bus, nobody can take them. Nobody dare to take the bus. So keep the driver there. Okay. These are the guided bus system. Okay. Until this time, tell me, is this a rail system or road system? Is this a rail system or road system? What's your idea? This one? This one. It's a rail system? Is this a rail system or road system or combination? Which one? Road system? Both? Mm-hmm. How about this? Rail system, road system, or combined integrated system? Okay. Combined. Yes. Combined, integrated. Okay. The difference between rail system and road system is becoming less and less. At last, we will have one integrated transport system. Okay. Guided bus has rail infrastructure. Yes, rail infrastructure. But sometimes running on common road. Yes? Don't forget, the difference between the road and the rail systems is becoming less and less. At last, we will have one integrated traffic or transport system. This is the future trend. Okay, let's check other systems. Oh, do you have a break? Do you want to have a break? Do you want to have a break? Yes, okay. let's have 10 minutes break, okay? It was introduced in the year 1986, okay, for the Expo 1986. In fact, it's an intermediate capacity transport system in Canada, okay, first in Canada. You can see a common train maybe, but let me tell you, no wheels. This train has no wheels. Okay, similar like the suspended well trains very fast or in the world. To my knowledge, this system was imported into in Nagoya in Japan for the Expo 2005. Okay, this system also like like MagLab. Okay, but in fact, it was first time introduced in 1986. Okay. Until today, I think in Guangzhou, in China, we have this system. In Shanghai, there is another one, but it's different. It's a high speed, linear motor car, but this one is a low speed linear motor car with a speed of about 100 kilometers per hour. In the year 2005, for the Expo 2005 in Nagoya, in Japan, they also imported this system for the passenger transport. But until today, it's not very welcomed in this world because the equipment can be utilized for a longer time because there were no wheels for the trains, no frictions, no waste. But this system utilizes the electricity with the low efficiency. Okay, usually 3 or 4 times of the electricity energy consumption. Very low efficiency. So until today, this system is not widely utilized in the world. Even it can have less frictions, less wastes, but more waste about the energy. Okay. This, okay, 1985. 1986, another one. First introduced into this world. This one. What did you see? What did you see? A small bus with the rubber wheels, but running on very special tracks. In fact, this system was introduced in 1986 in Miami, in USA. It's in the city center of Miami. For what? You can guess for what? This one? The purse is very small, cannot solve the problem of mass rapid transit. But for what? Elevated track. Yeah, elevated track. For what? To reach the downtown. It's inside downtown. Inside downtown of Miami. Okay? Helps traffic congestion? Yes, helps traffic congestion. How? Move inside downtown. You're reaching to the answer. Okay, go on. Less noise due to rubber wheels. Yes, less noise. Rubber wheels. You can see in the downtown of Miami there were many skyscrapers, right? Too many skyscrapers. And in each skyscrapers, there were many people there. Okay, they work there. Sometimes inside downtown, people need to move between skyscrapers. Okay, capacity is less. Yes. Guided way. Yes, guided way. Guided way. Guided way. People need to move inside downtown, especially between skyscrapers. Okay, if without this one, people need to, for example, if you work inside this skyscraper, you need to get down with the elevator and get into the get to the road and walk somewhere or take bus on the road to somewhere and then get into another skyscraper. Okay? But if you utilize this one, for example, you can get into this one at the second or third layer of one of the skyscraper, and then to get to another stop of this metro mover, and then get into another tall building at the second or third or fourth layer of this building. In this way, the traffic congestions or pedestrian congestions, okay, this issue is solved. Okay, inside downtown. To solve the issue of pedestrian, or can say pedestrian flow intersections, pedestrian flow, well, congestion. Okay, very small. Because we don't need a big train. We don't need a big light rail. Just a small one. High efficiency. Okay. High frequency, small vehicle, okay? And then frequent movements of the people inside downtown are solved, okay? And also the rubber wheels, less noise, okay? The main purpose of the metro mover in big city, in the downtown of a big city, is solve the problems of the pedestrian flows between tall buildings. Okay, the station usually is at the second or the third layer of the tall buildings. Okay, metro mover. Okay, bus is a single bus service like that might have been. Okay. No. Sorry, I didn't see. But it's a single bus service like that might have been uneconomic to run for the transport company. Advantage of rail car is the belt movement. Yes. It's a single vehicle, but very high frequency. You can see this one here, maybe another 30 or 40 seconds, you can find another one is coming. Okay. High frequency movements. Okay. Okay. Thank you. Okay. Let's check another one. This one. It's a light rail. A special light rail. Okay. Maybe you are familiar to the light rail or monorail with the riding mode. Okay, that means the tracks is just beneath the trains, but this one is called suspended monorail. You can see the tracks are here, but you can see the train just under the tracks. Okay, very special. This system was first introduced in the year 1988 in Japan. Okay, it's called suspended monorail in Chiba, in Japan. Chiba, not Chiba, Chiba. It was the longest suspended monorail system with the length about 15.2 kilometers. Okay, but today it's not the longest one. The longest one now is in China, in Chengdu. Okay. See, another monorail, very special monorail system. Okay. How about this? What did you see? This system was built in the year 1994. Okay, it's called Streamline. Main advantage of monorail. You mean this one? Advantage of inverted monorail? You mean the suspended monorail? This one? Yeah. Side view. Especially very good for tourists. Not only for transport, but also for tourists. Okay. Okay. Thank you. Because if you stand inside this train, you can see a very wide, very clear views of the city. Okay. Usually such lines will connect the main, natural viewpoints or commercial points, okay, inside the city. Okay. For not only the soft problem with traffic problems, but also the tower problems. Okay. Another one, this one. Astrom line in Hiroshima, in Japan. You know Hiroshima? Hiroshima and Nagasaki. Yes, for the atom bomb. Very famous. Okay. This one was introduced in the year 1994 in Hiroshima. Okay. Survivor automatic bombs. Yeah. I was there for 5 years. No problems. Astrom line. What did you see? Very common light rail train. Yes? Very common. No special. But why I want to tell you this? Why I want to introduce this? Listen to me. This is very important. Okay? Astrom line, in fact, is a very common light rail line. No special characteristics. But this line connects the Asian Games main points and the city center. Okay, in the year 1994, for the Asian Games held in Hiroshima, okay, Japanese take this light rail line connect the city center of Hiroshima and the main stadium of the Asian Games. From that time on, for Asian Games, for the Olympic Games, no matter in winter or summer, if a city wants to hold such a game, okay, then you can find a light rail or metro line connecting the city center and the main stadium. In other words, this line start the time of a light rail or metro line connecting the city center and the big sports stadium. Okay? No new infrastructure, no new equipment, but new idea, new management idea for the big sports, games. This is very important. Okay. We are major in transportation management. We are not major in infrastructure. We are not major in vehicles. We are not major in engines. We are major in transportation management. How? Give the new idea to improve the operation efficiency of the whole transport system by utilizing, remember, by utilizing the existing infrastructure and equipment to have the new operation ideas, new operation management ways to get a new or a higher operation efficiency. Okay, this is the key point. This means no new investment for inventing new equipments. We can do new jobs. Okay? This is a key point of transportation management, especially in the integration of different travel modes in the future. Okay? Do you agree? Yes, thank you. Thank you. Thank you very much. From the year 1994, Japanese connected the city center and the Asian Games Stadium. Okay? No matter it is a Asian Games or Olympic Games, you can find a light rail or metro line connecting the city center and the main sports stadium. Okay? Really important. Another one. Let's check. 1998 and 1999. This is hard to explain. Do you know this one? Yeah, tram, not tram. Not before. Yes, before 1945. Before 1945, I mean, during the time of World War I or World War II, there were many such streetcars. Okay, trains are running on road, trains are running at the center of a road. Okay, especially in Japan, in UK, and also in US. Okay, many such trains. When the train runs, you can hear it down, 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 down like this. Okay, with the speed about 25 kilometers per hour. Okay, and the cars like this, the cars in this side or the other side, running this side or the other side. Okay. After World War II, people find that this one has a very old equipment, very poor station, let's improve the vehicles, let's improve the wagons, okay, to complete a new improvement, okay, for the platform, for the train. This is the train here, and this is the inside of this train. You can see. To solve the traffic problems on the road. Okay. Until today, until this time, maybe somebody is very curious, of the problems of traffic congestion. We can solve the traffic problems by constructing metro lines or light rail. What is the use of this travel mode? Remember, if we want to solve the traffic problems by utilizing the metro lines, first of all, let's check the demand of the passengers. This is really important. If we don't have plenty of the passenger demands, or in other words, inside a metro train, then few passengers. Or we can take an example, if we have the operation of a metro train, the number of the passengers is equal to the number of the passengers of several buses. And then it is a waste, a big waste. You need to remember, everybody knows that metro train, light rail train is sustainable, but not always sustainable. If we don't have adequate passenger travel demand, and then the metro train or light rail train is unsustainable because the trains run fast. They consume electricity consumption, energy consumption. They will have the energy consumption much, much, much more. How to make it sustainable? Plenty of passengers. And then for each passenger, we have less energy consumption. This is called sustainable. Okay? Okay, let's check. For this route, if we can construct the metro lines, and then you can see the passengers are like this. But very fast metro train operation. Much more electricity consumption. It's a waste. So no metro lines. How? Let's improve this system. Not fast. Usually a metro train will have the speed about 80 kilometers per hour. A light rail line in China will have the trains operating on the track about 60 kilometers per hour. Remember, with the higher, with the faster of the train runs, the energy consumption intensity is big. But for this system, 25 or 30 kilometers per hour, okay, the energy consumption is less. Less passenger, less total amount of energy consumption, and then for each passenger, okay, it's sustainable. Okay? So don't want to solve the traffic congestion problem, don't want to solve the energy saving problems, always utilizing the metro line, focusing on the passenger demand first. If we don't have that much more, passenger demand, and then focus on other rail traffic, or sometimes very special BRT, and then it's called sustainable. So in Japan, in Europe, they find that people need smooth traffic, but not that many passengers. Okay, let's improve such streetcars. It has tracks, okay? It runs comparatively fast. Okay, let's have this one. In UK, they eliminated this one in my memory. But in Japan, for almost each big city, they have this one. Okay, if you get into the train, okay, you can see this one. Okay, put into the coins here, and then you can take the train to almost everywhere of the city. Okay, comparatively cheap, comparatively fast. Okay, comparatively okay, sustainable. Okay, so here, until this time, I want you to remember, integrated transport system consists of the transport networks of different travel modes. This is the first point. The second point, even inside even inside the real transport mode, for the network of real transport, it has several layers. Several layers. First layer is the metro lines. Solve the problems of the odd rail transport corridors. The second, light rail, for the minor transport corridors. The third is this one. Okay, not important corridor, transport corridor. The fourth layer is this one or this one for the connecting or sometimes important but not that important directions transport. The fifth layer, common bus. Okay, I can tell you one of the mistake we made in Beijing for the rail transport system is that our rail network has no layers. I hope you can avoid such mistake. Okay, or it will be a very big waste, very, very big waste. Okay, in the peak hours, full of passengers. In non-peak hours, okay, no passengers. Okay, that will be waste. So make your systems, make your transport systems with different layers. Inside each layer with sub layers. Okay. This one. And another point I want to tell you to remember that with the time past, China now is stepping into the age of the elderly. Okay. Or more than 20% of the people with age over 60. Okay. How about in your country? How about in your country? What's the percentage of the elderly? 10% or 15% or less than 10%? Do you know that? Nobody knows? Age 75, 20 to 70, percentage of what? Percentage of the elderly, the people over 60 or 65. Do you know that? About 10%? 20 to 25? That high? The percentage of the people in your country with the age of over 60 or 65? Well, guys, maybe not 20. If a society has the population with the age of 60 or more than 60, 20% or 25%, then it is a node society. And then we have problem. 10%, I guess. I guess this one. 6 population is 25 above. In Pakistan, where's the president? Wow, 4.2, about 4.2. Okay, you're a young society. But, you know, 20 years ago, China also about 5% of the elderly population. Only 20 or 30 years later, you will face up to the same problem in China. Okay? Make preparation in advance like this. Okay? Don't forget. Another system. This one is very, very interesting. Okay? Introduced in the year 2005. It is called Intelligent Multimodal Transport System. Demo in Expo 2015 in Nagoya. I was there. I was there in Nagoya in 2015. Okay. You can see here. This is the IMTS. What did you see? Two buses, right? Two buses, very common buses. Let me tell you. You can see the driver here. You cannot find the driver here. These two buses operate on the road together. In other words, this bus go first. This bus will follow. This bus turn right. This bus will turn right at the side. This bus turn right. This bus turn left here, and then this bus will turn left also here. How? You see? This is the mechanism. Sorry, it's Japanese. Because this system was invented by Japanese. Connected with magnetic pole? Yes, magnetic. It's not a common road. You can see the sensor here. This is the sensor. This is the sensors. You can see sensors on the road. Okay. I forgot the distance between sensors, about 30 or 20 meters. I forgot, sorry. The sensors, the first bus, the first vehicle will have the automated operation system, operation equipment. And then it will record the behaviors of the drivers and then utilize the sensors to tell the next bus. For example, here, this bus take a break, and then this bus will judge what should I do here to take a break here or take break immediately. Oh, this is one point. Another one, in order to make the safety distance between different buses, you can see they also use the magnetic signals. If these two buses, okay, stay too far away to each other, and then the magnetic force will make the second bus run fast. Okay, if they are too near to each other, and then the signal will tell the next bus to take a break, and then to keep the safety distance between buses. Okay, don't forget, no drivers here, only one driver here. Okay, in this way, remember, this is important. In this way, you can find another bus here. Oh, sorry. You can find another, you can connect another bus, another bus, another bus, another bus. Tell me, is it a train or bus? In this way, you can connect as many vehicles as you want to. Bus. It's a bus, right? Then tell me, what is a train? Tell me, what is a train? A train means many wagons, okay, connected with each other, and then running on special route. Many wagons connected each other, running on route. And then tell me, it's a bus or train? Really headache, right? And then you can have another definition of a train. A train connect with other equipment, not signals, then it's not right. Right? This one was invented. This system was invented by Japanese. Very expensive. In this way, you need very special road, okay, with the magnetic sensors, okay. Between each pair of sensors, you have about 30 or 20 meters long, and then you have special route, you have special vehicles, not very special, and then you can connect different vehicles by signals, magnetic signals, to keep the safety distance between vehicles. Okay, in this way you can have a road train, right? And as long as you want. Or in the future, you can connect all the cars, buses, trucks together on the road. Am I right? Do you agree? Hello? Use your brain. Agree. It must have a very high maintenance cost. Yes. Yes. Very high cost for construction and operation, maintenance. Okay. Now I will repeat what I told you before. The difference between rail and road systems is becoming less and less and less. The future trend is we will have a integrated system. Okay? Yes, systems are becoming integrated. Japanese utilize advanced scientific ways to realize this one. Okay? Because Japanese have much money. Okay? If you don't have money, look at this. Mechanics of this system, of the mechanic of that system, are they the same or different? Tell me. Don't forget, I told you before, in peak hours, this is one bus. When in peak hours, there were another bus, three buses, three drivers will move together. The mechanism of this system and the mechanism of that system invented by Japanese, are they the same or different? Tell me. Hello? Hello? Different? How? How different? Any different ideas? Let me repeat the mechanism this way. In peak hours, because BRT is consuming more human resource and energy. Yes, consuming more human resource and energy. I'm asking you the mechanism, the theory. The theory is different or the same? Theory is the same. The theory is totally the same. Okay? More units move together. Yes, more units move together. This one also, you can make the bus trains manually by utilizing more drivers. Okay? And these drivers must be trained, okay, for safety, for high efficiency. Okay? More buses move together. 3 or 4 or 6. Okay, as you like. Okay? This one? 3 or 2 or more? Okay, as you like. But by utilizing the magnetic signals, not human resource, the theories, their theories are the same. If you have money, use this. If you don't have, this one. Okay? The same theory. What theory? Train operation theory. Okay? Do you agree? They all utilize train operation theory. Yes. Yes. No matter you utilize the scientific equipment or utilize the human resource, road traffic system is becoming more and more like rail system. Okay? And the rail system sometimes will have the characteristics of the private car characteristics. Okay? This. No, this one. No. This one. High frequency. Small connections. Right? Flexible service. The rail system can provide. Okay? Large scale, rapid transit. Rail system can provide. Okay? So integration will be the future. Okay? In science. If you don't have money to realize the system by scientific tools, okay, you can use your ideas. You can use your brains to overcome the defects, the problems you have. Okay? This is really important. So, transportation management, how to manage, utilize the resource you have, take advantage of the money you have, then make different efficiency. This is what we should have. Okay? This. From the first page of this PPT file to here, in fact, I'm telling you only one principle. Okay? Integration.